cool. I think we'll get started here. There's no need for that. Well, since you're here, unless you just stop to sit down, you probably know who I am, but I'm Benjamin J. Heckendorn. I've been a modder kind of geek for about 12 years now. I started doing this back in 2000 when I built my first mod, which was an Atari 2600 portable. I was doing it as a hobby. At the time, I was a graphic artist, so a lot of people ask me what my background is, and that's what it was, graphic arts. And yeah, so that was about 12 years ago. I got into the portable gaming and whatnot, building cool little things. And over the years, I've diversified and tried some new stuff. And what I'm going to be talking about today is 3D printing, which you've probably seen plenty of at the show, but I guess you can see one more 3D printer. On the Ben Heck Show, which is our bi-weekly show that's sponsored by Element 14 and distributed through them and Revision 3, we build lots of cool projects. And one great thing about that is quite often I get to build projects that I've wanted to make for a while, but really haven't gotten around to doing or really been able to justify. Like the Portal shirt that you may have seen on the show. I had the idea years ago. Like, it was probably the Halloween right after Portal came out. Then it's like, that's, it was kind of expensive, but it was worth it for the show, so I was glad to do that. So last year, I decided to build a 3D printer, but I wanted to get back to my portable roots. So I was like, well, maybe it was a 3D printer and it could be portable somehow. So we put together a design and we had it at the show and it was working, and by that I mean it wasn't on fire or anything. But we had about 2 weeks to build it, and there's a lot of conventions going on, so it was kind of a tight chase there. So flash forward to last month. I was at this warehouse, a surplus place down in Chicago, and I found some stepper motors. Basically like our HSC, but not even remotely close. And I'm like, wow, cool. I could take these small stepper motors and maybe I could make a small portable 3D printer. So I bought them along with a bunch of other stuff. I took them home and I started looking into some ideas. Now I had built one printer before this, but other than that I didn't have a whole lot of experience. So I realized that the motors weren't quite powerful enough for what I needed, so then I just went with the standard NEMA 17s, which is what most 3D printers use. And then I'm like, okay, well, I'm just gonna use these standard motors, so can I build one that's portable? And the real kicker of this was 3 weeks ago. So I went from the design to a finished product in 2 weeks somehow. I really don't know how I did it. Maybe I had a twin and it conked me over the head like Rumpelstiltskin, I don't know. But I managed to do it because I did it as similar to my old printer as possible, which is a good thing in engineering. If you know something works, use it again until you can no longer get the part. So yeah, I'm going to pop open the portable briefcase printer and take you through each of the functions and kind of how I came about the design. So as you can see, it's 14 by 18 by 4.2. These are the dimensions. Weighs about, I don't know, 2.5 gallons of milk. That's, standard measurement, so I'd say about 20 pounds. It's got like these clamps here. You just open them up. Well, I won't have time to print anything on stage, but I'll make it move around and stuff. So it opens like this. Now the printer last year had that same premise where it would, let me scoot it over a little bit here. Had the same premise where the sides would open and then this structure would be intact. Because this is where you need most of the structure, so this shouldn't move. The moving part should be something else. Once you've opened it, put this over here, you slide the wide carriage over like this. And I don't know if it shows up on screen. You can kind of see here with these two holes. The wide carriage is cut from a big fat piece of 1/2 inch Sintra, which is a type of PVC plastic. And what that does is when you slide it over, it goes into these V channels here. You can see how they've got the nuts going through, but this is a V shape here, and there's a V bit here, so they match up. Now what that does is it creates the stability of the unit. So this basically is kind of like an outrigger, so to speak. I'll plug it in. Nothing like a talk to make you more dehydrated, right? All right, turn this on. Okay, so can everyone see it pretty okay? I mean, I know the resolution's not that great, but I can point out the parts for you. So this is obviously a standard Prusa heater bed. It's a 200 by 200 millimeter area. One of my original design goals with this was, it's not one thing to just make a portable printer, but it should have like a full print area. I mean, it'd be easier to make it have a small area, but I'm like, full print area. So this can do 200 by 200 by 175 on the Z millimeters. Yes, I know I went from inches to millimeters, but whatever. I still can't think in metric. I can 35 millimeter because film, but nothing else I can think of. Then on Thingiverse, they have the Alta panel control. It's a vowel. So what this is, it's just a schematic you can get. You can hook a Hitachi 4480 up to the ramps and control it manually. So you can print it off an SD card. It's kind of rudimentary, but it does work. Let me get this here. I will Z it, prepare. And a lot of times, limit switches don't always need them on a 3D printer because quite often you just go from the center. But in this one, obviously knowing where it is and being able to auto home, so you don't have to fiddle there with prompter face in a computer is very important. So I put all the limit switches on this one. So while this orients itself, I will talk about the design process and the parts. So the first thing that I go from the inside out when I do designs like this. You see here, this is the X carriage, and I had a Maker Gear extruder motor, which is a NEMA 17 with a gearbox. Although I guess people are just direct driving them without the gearbox, but whatever. So one second here. Oh, I didn't have that fully over. So I use that as my base point, but you can't quite see it on screen, but it is, the motor's at it's not at 45 degrees, it's at 90, because I wanted the X carriage head to be as thin as possible, so this could be as thin as possible. So I designed that first, and I also changed the extruder where it just has this quick release thing, so you just got this spring-loaded bolt here, and then you open this up, and then it has a bearing there, which uses a lever action to put a lot of pressure on it. Because that's one thing about filament, it's often is not a consistent thickness, and if you design it as such, so you always assume it's 1.75 inches. If the filament's too thin, you'll lose traction. So there's a few other simple G codes that I have on the card just for easy control. Like one of them is center. That just raises the Z and then centers it. So the question you're probably asking is, how did I get this on the plane? Well, they didn't really care. It was really strange. They went through the machine, and I thought it was going to be like, like 3 times, but then it just came out, and Lena's like, oh, what's that? I'm like, it's a 3D printer, and she's like, okay. So we'll see on the way back. I have a feeling it probably won't be as smooth, but whatever. So there's a little filament stuck here, but that's all right. So yeah, once I had the X carriage as thin as possible, so it fit in the case, then I worked on the end pieces here. And these were lasered. So everything white is PVC plastic, and that was made on my ShopBot, and all the wood stuff was lasered on my Epilog. So it's it's a sad truth that the easiest way to make CNC machines is with CNC machines. But yeah. So I got these brass bushings from Chris Kraft, who's my 3D printer mentor. And the thing that's good about them is they only you got the 8mm rod, and the bushing only takes a little bit more space. So if I'm trying to make this aggressively small design, that helped a lot. One thing you might just barely be able to see, the height of the heated table is also very aggressive. There's a slit in it here, so it can pass over the motor. There's also a slit underneath here, so it can pass over this pulley. So I was very aggressive with the size. I'm thinking about building more of these. It doesn't need to be that thin. If I even make it ½ an inch thicker, that'll make it so much easier to put together. So let's see, what else can I talk about with this? So once I had this part figured out, I had to move on to the design of folding it and making sure there weren't any collisions. And that was obviously the really, really difficult part. But I did do it. So I definitely wanted to have the power supply in place. I get these little black ones here from, I guess you can't quite see it there, but from Tiger Direct. They're kind of expensive for a PSU, but they're consistent and they're small and they got enough juice, and you can see it's not that big. And over here, I have the Ramps board, which is a fairly popular 3D printer driver board. It's got an Arduino under there, and it even has a little fan. And this was really tricky because the fan, this space right here behind the fan, had to have room for this. So when it folds up, it's very tight. And one design oversight that it has is the belt, when it's in the park position, goes right up against these stepper motors, stepper drivers here, which isn't good. But it actually, can you see it here? I guess you can't. There's 2 heat sinks, and this belt, when it's folded, goes right between them. So it's that it's that precise, and I don't know if precise is the right word. It's more like I was doing it by the seat of my pants. Otherwise, it's basic kind of rep-rat thing where it has 2 Z-drive motors here. We have the 8mm steel rods and whatnot. And I printed the pulleys with my old printer. So the old printer was making its replacement. It's still a good printer though. Yeah, so it's been a lot of fun doing 3D printing. I had to admit, in the past, I thought it was interesting, but I personally didn't see the use, I guess you could say. But then, one magical night, we good? Okay. One magical night, I used a 3D printer to make a prototype part for the pinball machines we work on. So my hobby, which I'd like to, turn into business someday, is pinball machines. And I've been working with John Papaduke, who's a classic designer back from the 90s. So we've been working on new games, and the 3D printer is excellent. The prints might not, they don't look super great, but they're excellent for building a physical thing that can take abuse. So for pinball prototyping, it's a gold mine. So once I did that, it is clicked in my head, and I'm like, I love 3D printing. We even have so the prototype game we're working on right now is about, it's a spoof of all the paranormal hunting TV shows on television. So there's a Ouija board ball, and the ball comes down, there's a magnet under the playfield, and it captures the ball, makes it move magically to like the letters. And I have a stepper driver and a motor and a belt much like this, but the end brackets I designed and we 3D printed, and I actually did it with Autodesk 123D. And so stuff like that has been really great, and there's a hand on the playfield, like coming out of the playfield, and that's a plastic target. So I really enjoyed it. It was the killer app for me, and I'm glad I found a use for it. So I still like the laser stuff, and the ShopBot's good too. Yeah. So how are we doing on time? How are we doing on time?
Oh, we're doing fine. You got another 10 minutes ago.
Oh, okay.
Yeah, you're fine.
Yeah. So let's see. Is there anything else I should talk about? Oh yeah. So we've already documented the construction of this. So it's going to be on an upcoming episode of the Ben Heck Show, so you can get even more detail and close-up views. And we actually shoot the show in HD, so it'll look better than that screen. So you can get a better close-up look. And I've already started, any of you that have ever built anything, which was probably most of you since it's Maker Faire, as soon as you get done, you're like, okay, now how could I do it better? So I've already started the design for the new one, which I think is going to be all laser cut, because there's some unwritten rule that 3D printers should be laser cut. And I might even put it on Kickstarter, why not? My idea is, a friend of mine wanted me to kickstart an independent film about killer deer. And I'm like, I don't think that would succeed, but what if we did a Kickstarter for 3D printers, which is like this ridiculous success rate, and then use the profits to make the movie? So we'll see. Yeah. Oh, and the firmware is Marlin, which is a derivative of Sprinter. So that's a great thing about the online community and the whole open source movement, is there's always software out there, and people are always taking something like Sprinter and improving it, such as with Marlin. So it's great. My ideas for change. Okay, so this, it's wiggly. It's not actually as big of a deal as it looks when you're printing, but it needs to be better. So I want to put some buttresses here, flying buttresses, so to speak, to give that more stability. John over at the RepRap table was suggesting using aluminum extrusions, so I might look into that too. Maybe even MakerSlide. I haven't used it myself. I guess we'll see. I would do that. So I flew from Madison, Dallas, San Francisco. So in Madison, we had a little Embraer, like the 3-seat across plane. It just barely fit in the overhead bin. But I did not want to put it in the checked baggage, because you would not be seeing it. You'd be seeing a box of parts right now. So knowing that it will fit even in a dinky Embraer overhead, but just barely, maybe shave half an inch off this way of the height. Stuff like that. Basically more stability. Probably nylon bushings instead of the brass ones. I had the brass ones because a friend of mine had a bunch of brass bushings, and he's like, and I'll sell them to you cheap because I don't need them, and that's why I use them. Necessity over what's best. Yeah, and then this part, maybe a little bit more stability. Oh, and this, the PrinterBot guy was gracious enough to give me one of his driver boards, which of course I'm going to immediately put into one of my printers. So I think he's okay with it. I would hope he's okay with it. Ramps is an Arduino on top of a driver board on top of Pololu steppers, so it's like about 2.5 inches high itself. So shrinking the electronics down and making sure they don't hit anything, and also a proper energy chain, which I know you can 3D print, but this is it's a mess. It looks like that thing where they take the bodies and like make them out of plastic. That's what that looks like. We have a few minutes left. Any other questions? You look like you have a question.
I was wondering how you decide on particular dimensions. Were you just going for a hole as small as you could make?
Yeah, well, I guess the dimensions derive from, first I designed the X carriage. I'm like, how small can I make that? Then it was, okay, if this thing comes, if I'm gonna, this is a known factor, Prusa 200 millimeter square bed. So I'm like, all right, so if that bed's in here, so this head has to come a certain distance over here, and then of course, the extruder head isn't centered on this extruder part, so you lose more area here than you do here. So yeah, this is probably better resolution than the screen, isn't it? Seeing it in real life. So if the bed's here and the tip is here, that means you need this to be this far over. So basically, then you put it right on the computer screen and you move this over here. You say, okay, that's how much movement I need that way and that way. So basically everything expanded from here's the size of that, here's the travel area here. And then once you start putting it together, okay, well that means it's going to be this high versus this long. One trick I had to do was the only place to put the hinges for the sides were down here, because obviously you can't put them here because they'd collide. Therefore, the Z motors had to be lifted up about 6 millimeters so the hinges could be under them, which of course increased this height. And then you can't really see it, but right here, this block actually passes over the coupling, and I did that so that it could get lower, so you could have more stability here. But you know what I mean? Because if this can only go that far, then that affects how far that goes, which means this either has to be higher. Yeah. So basically, I was just basically as aggressive as possible, as small as I could make it, and still have the full print size. Anything else? Yes, sir. What have I printed so far? I printed a 175 millimeter tall tube to test it. The first thing I printed on it was gear. And I printed it and I taped it so I could take it with me if I had to explain to the TSA what it was. And of course my calibration gum, which is where I have, it looks like a stick of gum and it's got 4 holes in it. And then I print it and I hold it up against something I've done on my shop bot to see if the alignment's all right, to fine tune the steps per inch. And then I printed, I printed a pen holder and some tags that say like benheck.com and Element 14. And speaking of Element 14, after the talk, we've got a table full of swag, and you can sign up to win this or any other cool projects. So definitely hit the swag table and they'll hook you up after the talk. But yeah, this thing has basically been around, it's been in existence for like a week and a half, so I haven't printed a whole lot with it. Any more questions? Otherwise, you can come up for a closer look. Yes, sir. Oh, you had one. Yeah. It's, the hot end is a Maker Gear, 0.35 millimeter, and the extruder, I actually made the extruder myself, but it's using the Maker Gear extruder motor with the gearbox. Again, the Maker Gear extruder has those the four things you plug in. It's kind of cumbersome, as is the Bird extruder. So again, the main thing was to make something as small as possible. But it actually works pretty good. I haven't had any material slippage issues. And you had one? Oh. Maybe. But easy is sometimes good, because it makes it accomplish. Okay, anything else? Otherwise, feel free to come up and take a closer look. And of course, hit the swag table. The what? Oh, the rest. Well, once there's a CNC controller in the Raspberry Pi, I'll look into it. I'm sure someone will beat me to it, though.